that enjoy this webinar.
Yeah. Hello, everyone. Hi, Dr. Ihab. Hi, everyone. I'm going to present. Okay, let's start. I'm going to present some topic which is interesting nowadays, and even it started like from 5 years ago. Everyone, it's more like a hype right now concerning how to build smarter language models using RAG. And so, as we can see in the diagram, it's more like taking the user query, having a knowledge base, try to retrieve some documents from the knowledge base that are relevant or similar to the user query, and to get better enhanced response. Before digging into RAG, I would like to introduce myself as well. I know like Dr. Ihab already introduced me, but a few words more, I guess. I'm a Lebanese graduate. I graduated from also from the master's IDSS, Information and Decision Support System, from the Lebanese University. And then I did my PhD in Cototel between Claude Bernard Lyon 1 and Lebanese University on the subject of processing, processing and analyzing unstructured data in real time in order to predict delay and try to do route optimization. Then I conducted my postdoctoral research at COA, focusing on machine learning, incremental learning, concept drift, where we built a Streamer framework, which is an open source right now, and it's accessible for everyone. Also, since 2022, I started at Meltwater as software data engineer, where we collect data from all the web, especially social media, but it also covers all the media data. Just a second, I think I'm not sharing the slides well.
Yeah, now you see your profile, huh?
Ah, okay, I see. Maybe I can. Otherwise,
so you have to share the whole screen, the entire screen, not only the window.
No, yeah, I guess so. Let me do that. Yeah. Stop sharing and then share entire screen.
Yes, now is perfect.
Yeah.
Try to switch between slides, please. Yes, okay.
So yes, sorry for that. At Meltwater, actually, we collect data from all over the web, like all the media, digital data, in order to generate insights for the clients. And so we are dealing with massive amount of data, and mainly I'm working with Scala. We work with Scala due to several reasons. We can discuss that in, later afterwards, maybe, or maybe in another talk. Yes. In the following presentation, I'm gonna give you a brief overview to RAG. What is RAG? And its components and framework as an architecture of RAG, and then we'll dig a little bit into vector embeddings and search due to its importance for understanding how RAG works and why and how we can build RAG systems. And also, it's very interesting for people that are beginning to dig deep into LLM and trying to explore more about it. Then we will start talking about building a RAG system, how to build one, advanced RAG techniques, like we have several RAG techniques that considered as advanced. We will tackle that a little bit in details. And then we will show like different evaluation metrics, and afterwards we will discuss a bit, if we have time, about emerging RAG research. After that, I will show you like a demo application on how we can build a POC for RAG, or even you can start from there building your own RAG system. RAG, as a name deduce, like as you can deduce from the name, it's more like retrieval augmented generation. So it's more like an integration or a combination between two systems, which are retrieval system and generative models like LLM. It was first introduced by Luis and Al in 2020 under Facebook AI research. It also allows to enhance large language models with external knowledge retrieval. Why RAG matters? Actually, we have different issues right now in LLM that RAG can solve. Like it addresses hallucinations, it provides up-to-date data. In case you have like private information or private documents, you can provide to the LLM in order to start reasoning on. Also, it improves factual accuracy and citation capabilities. So, as you can see here, we have limitations of traditional systems, and we have RAG, which is more or less similar, but with more retrieval capabilities. So we can see like when the user like has a query and he posted on LLM, traditional LLM, it usually like uses pre-trained knowledge from weights, which is, as we know, like we have in LLM something called cutoff training time. For GPT 3.5, it's 2021. So if I want to have knowledge about 2022 or something that emerges in 2024, I cannot get that information. And also there is something related to limitation to training. Same thing can lead to hallucinations. And also it can, like if I want certain rules for certain institute or certain company that are also like confidential private information for that company, I can't use like LLM without additional stuff like RAG or full retraining, which will be very costly. So, and one of the most interesting issues is limited context window size. Currently, like we have certain limitation whenever we want to provide data for the LLM as a prompt. Like GPT 3.5 has 4K tokens, other models has 8K tokens, and so on. So we cannot provide all the information that we want to reason about all at once in one pass. So that's also something like RAG was built for. Like we can also split the data only, like for example, as you can see here, the query is embedded into the user query is embedded into an embedding, and then it was we do vector search over vector database and generate get all the similar documents, adding them to the context, sending the user query and the context back to the LLM to get more enhanced up-to-date more enhanced response. And also like we can get more benefits from using RAG. Like we can allow real-time data external knowledge, for like adding more data to the model to understand more like real-time, or even not necessarily be real-time, like confidential information, knowledge domain for certain domain expertise. Like I want a full LLM model that work only for finance data, and it should have access. It has access to some confidential information, or not necessarily confidential information, since it would be like too much for LLM, but unless it's local, like private information for the company. And also we can have more verifiable sources and citations. That's the problem of RAG. That's why we need RAG. And now, what are components of RAG? RAG architecture consists of several components. As you can see, we have the chunker, the one responsible for splitting the documents into smaller pieces, which are called chunks. Actually, it's very familiar with what you already know about networking, where we send data in chunks. Also, we have the embedder, the one responsible for converting those chunks into vector representations. We will talk into that like in details. We'll address that in details later. All of these embeddings are stored in something called vector database. Vector database is some sort of database that is more specialized for doing for storing embeddings and undergoing search algorithms to get similar embeddings data in very efficient way. And after that, we have the user query, which we undergo query processing, and then we use a retriever, which will compare the user query to the data, to the embeddings inside the vector database in order to get all the relevant documents, adding them to be the context of the prompt and the user query as well, in order to use that and to use that in the generator to generate LLM response or more customized response as well. That's the architecture. In order to understand more, like every time I'm saying embeddings, I'm saying vector database, in order to understand what is embedding, that's why I introduced those slides to explain more in detail, especially for beginners, especially for people that are not used to working with embeddings. So we have dense. What is embedding? It's more like a vector of high dimensional space, like it's a vector of numerical values that represent a lot of numbers, like table-like or array-like presentation. So words and phrases. Sorry. Words and phrases with similar meanings are positioned closer to each other together. So in a way, like all the similar words are positioned with a table or array of numerical values that is close to other similar phrases. Also, I will give more examples on this, but just to understand, like it's more like presenting like words or text chunks of data, whatever you want to represent as a dense numerical representation with a lot of numerical values in a way like close values or related values are grouped together. There are a lot of embedding models in the market. Some most important ones, I would say, OpenAI's text embedding ADA, BERT, sentence BERT variants, BGE embeddings. We have GINA embedding, which I didn't mention here. It's very interesting for working with multilingual data as well, like multilingual from multiple languages, supporting multiple languages at the same time. And also instructor embedding, where we do embeddings for certain words with their instructions in order to perform specific tasks. As you can see here, to simplify stuff, we have word king. It's represented by, it's an example, so it's not the real values, by certain array or let's say high dimensional vector. And so it's more like that in the real world, like similar stuff are grouped together, like cat and dog are a bit similar, or vehicle, car, truck are also grouped close to each other. Animal, mammal, and so on. Human, queen, king, royal are grouped together as well. But in reality, it's not a 2D dimension, it's hundreds of dimensions, even more than a thousand sometimes. So in order to deal with those embeddings, we have similarity metrics, and we have approximate nearest neighbor algorithms that use those similarity metrics. Similarity metrics, I guess many of you are familiar with cosine similarity, Euclidean distance, dot product with their implications as well, like measuring the distance of the angle between two vectors, or the full distance directly between 2 points, or simple multiplications of vectors. As ANN algorithms, we have many of them, and one of the most popular is NSW, which I will explain in briefly later. Hierarchical navigable small word, due to its it's very interesting and used in many vector databases. Also, we have IVF. It's similar to the OS IVF, and PQ for memory efficiency. Also, there are some implementations, FIS, I guess Maisa once talked about it. And we have a noise scan and an MSLab, which actually MSLab is used right now in some of our features at Meltwater for generating clusters and measuring their distances. The number of data, number of records to generate image clusters is not that much. That's why we used MSLab like as a proof of concept, and for now it's still running in production. But we are planning on changing that later if we need more data, since it's in memory. In order to get more like how the nearest neighbor search work in action, we have, for example, the word monarch. And we want to see which of these words are the top nearest neighbor for the word monarch. As you can see here, we have a human, queen, king, royal. So it's automatically like after doing the search, greedy search, and so on, we place it like near queen, king, royal, since they are the top 3 nearest neighbor. And in order to see a bit more, it would be interesting. I don't know if I can. Let's see. Yeah. Okay. One of the nicest simulations about embeddings is the following. As you can see, all of these are embeddings. I don't know if you can see my screen, like the web interface.
Yes, cool.
Okay. Yeah, so all of these are embeddings, as you can see, just to imagine how things work, like in vector databases. For example, we are interested to know more about professor, let's say. So, professor. What are the closest or top nearest neighbors for professor? Like we have university, we have scientist, doctor, institute, researcher, doctorate, etc. So it's pretty nice actually to play with this in order to understand how stuff are, how, let's say, things or keywords are being embedded, and then you can do a search over it. Of course, the search algorithm is not really mentioned, I guess, here, but yeah, you can have your own search algorithm in order to do that, like HNSW. Hierarchical Navigable Small Word. So what is it? It's an efficient graph-based algorithm for ANN, and it's used in many recommendation systems and vector databases. As you can see, it's multiple layers. We have the most dense layer, I would say, where we have all the nodes, and we have upper of it, we have more compacted layer with less nodes, and the upper one where everything starts is more dense, like it's least dense layer with fewer nodes. It's pretty interesting to see, like, we don't need to do a brute force over all the embeddings in order to get results. It should be fast, it should be efficient, it should be very computational light, like it's not that expensive. So we can see how things are being done in H and SW. For example, here, we start by a query. We see which nodes on the topper layer, which is less dense one, is close to this query. For example, this one is closed or this one is closed. Then we see in the next layer which is closer to this node, and so on, like zooming into the full graph until, but instead of zooming in like a random way, we are zooming in a very concise way, going into which one is closer to the query of the user until you reach the let's say the top nearest neighbors of that query. We have different parameters for this algorithm, like max connections and EF construction, EF search. Now, how we can build a rack system? Now we know most of the stuff, like we know the embeddings, we know vector database, we know like how things are being done. So what should we consider while building a rack system? We should load documents or ingest documents, or do you do whatever you want, like you find suitable. We do text processing and cleaning. We do the normal data science job for processing data, or data engineering job for processing and cleaning data. And then we can split the data into chunks. Also here, there is something interesting which we'll talk about a bit, like a challenge, which is what should we consider like chunk size or as an overlap, or what strategy should we use for such methods. After that, we generate embeddings based on the chunks. For each chunk, we generate an embedding. Uh, Also here, there are a lot of models, as we said before, like you need to choose carefully your model based on your use case and store it in a vector database. And then we receive the user query. We do the embedding for that query, convert text into vector representation, and then we check for the vector database for all the relevant or similar embeddings and add them to the context. I'm passing the user query and the context to the LLM to do the reasoning. Like, I want the question, I want all the documents that are relevant to this question in order to do the proper reasoning from those documents in order to get better enhanced LLM response. Also, we can consider some re-ranking of results. For example, I want only like the question of the user was, what happened in Paris last night? So I don't care about the data or documents that were gathered from the vector database from 1 month ago. I really care about last night. So we can do re-ranking for the results to get more relevant content. As implementation steps, we have few here. So we have document processing, like loading document from various sources, extraction and cleaning, chunking strategies, fixed size, semantics, recursive. I think I talked about most of them. Retrieval methods, we have several ways of retrieving data. Like, as you will see later, we have something called metadata filtering for certain vector databases. Like, we are not just storing the vector or the embeddings inside the vector database. Also, we are storing different metadata fields like creation date, like, I don't know, like color, like several stuff. And it can be used for doing hybrid search or doing certain sort of filtering. So we have top K retrieval, we have hybrid search, we have ranking for relevance. As I said about re-ranking, it's mostly the same thing. Prompting strategies, we can, okay. For prompting strategies, it's more like what's famous nowadays. Like, we have few short examples. Like, I write some prompt for the LLM and say, okay, I want the result to be like the following, and I give few examples of that prompting in order for the user to get the same result. Also, instruction formatting, like a lot of instructions in order to get what I want. Also, this is so much used in production in many softwares. Source attribution templates also, it's more like providing referencing and references and citations for the results. For now, I will go through advanced RAG techniques. We have different RAG techniques, like they are considered a bit advanced since we have like original query, we do direct retrieval, we combine the results, we feed to LLM. That's the regular one, that's a naive based one. But what about like doing query expansion? Like, I need, maybe the user didn't write well his query. Like like most of the clients or customers, they don't really know what they want most of the time. So they ask about something and they expect another thing. So we try to enhance that result or that query with more precise terms or related stuff in order to get more enhanced retrieval and reach better results. Also, we can do something called query decomposition, like sub-queries retrieval, and then we do each, like, composing the query into sub-queries, and then for each sub-query we do the retrieval of the documents. After that, we do result fusion, like getting the full integration of what we have for the all sub-queries in order to get the result. One of the most popular is hypothetical document embedding, which is a bit different, where we ask the question, the user asks the question, then we try to do some hypothetical answer, like make hypothesis over what the user needs or what the user expects. And then we take the hypothetical answer and try to get more embeddings related to that answer before sending it to the LLM. Also, there are a lot more, like contextual compression. Like we need to filter irrelevant information from retrieved documents. Who said like everything retrieved from the vector database is relevant? As I said before, like I may be searching for Paris, but it's like vector database was a bit confused and said, okay, those are documents related to Paris, but they are not related to last night. And so they were returned, but it shouldn't be. So we need to do more filtering over the documents. Also, we can do summarization instead of sending all the document. The text of the document may be huge, so we need to do more summarization in order to have faster processing or less lighter processing. Ensemble retrieval, it's more like the ensemble classifiers. If you are familiar with the term, it's more like we have multiple embedding models, multiple retrieval strategies, and at the end we do fusion for combining retrieval results. Self-RAG and adaptive retrieval. It's more like when I should. It's more like when I should contact the vector database and get results from it. Should I do it all the time? Should I do it when the model is not certain? Like I'm not sure about the result, like as a model. Should I do it right now? I go fetch the data and ask for the vectors. Or maybe I know some of the answer, but I don't know all of it. So maybe I should take a piece of information and decide to retrieve that information from the vector database. Also, multi-step reasoning is the same thing. Like every time we reason about something, we think about it. It's not on the user query. It's more on the reasoning of the model. Like after step, like the user is asking for blah, blah, blah. So I need to check if this is found, I need to fetch it or not before fetching it. We have several evaluation metrics for checking if the model is functioning correctly or not. As we said before, like RAG adds some advantage for the LLM. So we can make sure of that. We need to have some metrics. So it's mostly like the LLM, current LLM system, where factual correctness, like accuracy of retrieved information, hallucination rate, answer relevance, like the hallucination rate, how much data is fake, answer relevance, how much of the data is related to the original query of the user. And so how can we measure this? We can have a source of truth where we already know like the answers of the questions. They are predefined, they are pre-known to us, and then we can do some calculation of over how many questions being answered correctly, and is this real information or is it a fake one or not. Also for retrieval performance, as it's performed over vector database, it is much easier to see if the results are relevant or not. So we can use recall and precision, the ones already known for everyone in data science. I would say it's more like number of relevant documents retrieved over total number of relevant documents. That's the recall, and the precision number of relevant documents in top K over the K. RAG vector database options. What do we have as vector database solutions right now in the market? We have Pinecone, which you will find a lot. It's a fully managed vector database service. I won't go over all of them, but I had the chance to do some experimentation with most of them, like Weaviate, Milvus, FACE, Quadrant, PG Vector, and OpenSearch, I guess, at that time, and Vespa, yes. And yes, and afterwards we decided to go with Elasticsearch due to its recent adoption for the vector search and their databases, and we already were using it, so we didn't want to complicate the system more, adding more stuff to our stack. So there are selection factors. We were considering the scale requirement, like it should be scalable, and also the filtering and metadata capabilities. Since when we are searching for images, embeddings, and so on, we need to check, like, I need an image with two people inside it, or two men wearing this logo, and so on. That's kind of search that's so complicated and so complex. That's what we were looking for in one of our projects. Common RAG challenges. Yeah, we can consider different challenges for RAG, like chunking strategy optimization, embedding model selection, like what model should I select, retrieval latency versus accuracy, which database should I select, same thing, token context limitation also, like, yeah, like that token context, which one to select for its token context limitation. We have different implementation challenges also, like how to do multi-hop reasoning. Should I do it before? Should I retrieve the data before? And so on. Domain adaptation, source attribution, and also handling contradictory information. Like if two documents or two people are talking in a contradictory way over the internet, how can we know which one got more credibility to consider his or her, let's say, talk, or his or her words as an answer? Yes, and also we can go, I don't know if I have much time. Let's see. Yes, I guess I can go a bit further. We have vector search optimizations. We have different way in order to optimize our vector search, like dimensionality reduction when appropriate. Of course, if you decrease like the dimensionality of the embeddings, you will get faster results, since the calculation or the similarity metrics, when calculating them, they will be on less dimensional space. Also, pre-filtering methods on metadata. For example, if I was doing like I want to filter the results for last night before getting into the data and saying, okay, I need all the results that are similar to Paris last night, it would be much different, and we will get much less data and more faster retrieval. Optimized vector storage formats. Also, we have like more optimized vector storage formats than others. And so we can do batch processing for embeddings generation, since it's a bit costly and it's a bit hard to do it in real time. For now, okay, we're almost done. We have emerging RAG research. As emerging RAG research, we have multimodal RAG, where we can deal with text data, including images, audio retrieval. For example, right now, what most of the people are doing are just storing text, trying to get the user query, and then get all the similar documents or embeddings from the database that are similar, that have the text similar to this, and then adding them as context, sending them to the RAG model. Whereas, what if we can do like similarity between, and we are doing it right now in some of the projects, like we are doing some clustering of images, and then adding title for each cluster, or several titles for each cluster based on the semantic search between images and text. So instead of just taking the text, we take images, audios, everything, and we send all of that to the RAG model to get more, let's say, enhanced and more enriched results. Also, we can have multi-step retrieval process, like we can take the user query, decompose it in different steps, and start each one refining it. This should be that, and so on, until we get all the data that are relevant to the user query step by step. Also, we can allow LLM evaluation to evaluate the retrieval content, like, is this really related to what we asked for or not? Like, it can do some evaluation, self-critiquing for retrieval. Is the retrieval what we are doing right now is really like doing well, it's not doing well? That's something as well. And one of the most interesting things that's being used right now in some agents is personalized RAG, where we have user-specific knowledge adaptation. Like I want the RAG to write emails like I do. So I give it all my emails, build some user-specific knowledge, like it can act like me, and write the emails same way as I do. That's also something that's pretty interesting in the research nowadays. As practical applications can be applied in customer support knowledge bases, legal medical document analysis, social media analysis, educational content personalization, and enterprise knowledge management. Some tools and libraries, LangChain, Lemma Index, Haystack, Gene AI, and Hugging Face sentence transformers. I would say Haystack and LangChain can do exactly the same thing. And even I want to recommend someone for real deployment. He can start with LangChain, but it's not something he need to keep for his projects, since it's adding a lot of boilerplate code that's not doing much, and I would think of it as useless at some point. And yes, for real application with complicated stuff, maybe you should do it. You should build your own pipeline, do the fetching on your own from the vector database, and try to enrich your model based on your user query and everything. Okay, now is the time for demo. Maybe before going into the demo, if someone has any questions, maybe he can ask right now, and then we can move on to the demo. What do you think?
Yes, we can take one or two questions at most, just to keep the enough time for the demo. So if you have a question, so we'll take two questions, okay? Ali Asi, go ahead, please.
Yes, I have only two questions. The first question about embedding model. I don't know. I'm curious to know how the embedding model is trained. What types of data used to be the training data? And the another question is when answering the user query, if the context was paradoxical with contradictions, for how the large language model decide the answer.
Thank you for the question, Ali. Actually, for the first one, of course, the embedding models are trained on very large data set of texts and embeddings. It's started from word to vec, if you know the algorithm and the data sets word to vec. That's where it starts, and then they start to train the model on very large data sets of word to vec data. Until now, we arrived to do full text, like we can have very big paragraph and we can do full embedding for that paragraph as if we are doing it for one word. That's what's interesting on current models. And for the other question, I think it's about embedding, like
it was about the paradoxical context.
Oh yeah, it's about the contradiction. Yeah, that's what I mentioned actually in the RAG, or maybe in the technical challenges. Like we have this sort of contradiction. Like what if we have contradictory information? Which one we should consider as credible? Which one as not? Still, it's more like challenging a little bit. But I guess they find something like in case it's contradictory information, we can go fetch the internet, find which one is more credible as a source, and we can say this is more credible source, so we should consider the information from here more. So I guess it's more for the LLM models. They had their own ranking system for even the sources, not just the information. Hope I answered your questions.
Okay, thank you. Thank you, Dr. Mohammad. I guess it's clear. So the last question for this part of the webinar, Hussein Jouni, تفضل. Go ahead, please.
Hello, can you hear me?
Yes, go ahead.
Hello, first of all, a quick thanks for the presentation, very concise, very knowledgeable. My question is, in the embedding part, do we have any, do you have experience in embedding models for the Arabic language? Do you have any recommendations for that part? Because I'm doing a project and I'm needing an embedder for Arabic language. So do you have any experience in that domain? Thank you.
Yes, I guess Gina embedding will work fine with Arabic language, but I'm not 100% sure. Just to make it clear, since I didn't work much with Arabic language.
Okay, all good. Thank you.
You're welcome. Okay. Then next we will go for showing small demo about. Okay, let's. Yes, okay. You can see my screen right now, right? Hello?
Yes, great.
Okay. This is a small demo. I will go a little bit into the code just to understand what's different. Maybe a lot of people did the same thing, and it's more like to understand drag here, not LLM, not just like LLM model. So what I will do right now is just to gather some paper. As you can see here, it's a paper about retrieval augmented generation. It's the one of Luis and Al in 2020. So we can see like the full paper being uploaded into the model. First, we create chunks. Those are the chunks of the data that are being embedded inside the memory right now, since I'm not using right now any vector database. But you can do exactly the same thing with vector database. This is just a small sample of the chunks, just top 5 or stuff like that. And now I'm going to ask a few questions about this paper. For example, what are the 2 variants of RAG model introduced in this paper, for example? For example, 3-way classification task, supports, retuits, not enough info, whatever. So we are really asking about this paper. So what is the subject? Since actually what's happening right now, we are taking the user query, transforming it into embedding, and then try to get all the relevant information concerning this query of the user and try to pass it to the LLM. Okay, let's see what training methods is used to fine-tune the RAG model.
Dr. Mohammad, what if we ask it a question which is not related to the article itself? For example, how to make a pizza. So usually she must she must not have a response for that, right?
Exactly, that's what happened. I don't know.
Okay, great.
So what's the best pizza for today? I don't know, since it's not in the context, so it can't know what's happening. So we can.
Sorry, what is the model you're using here? The LLM model, OpenAI.
It's OpenAI 3.5 GPT.
Okay.
I will go over the code a little bit just to explain more the stuff how it's working. It's pretty simple one, I would say, but yeah, still it can tell. This is actually the paper we were uploading, and this is the video we want to upload right now. Same thing, the video is being, actually we are downloading the audio file over the video, and then we are using the Whisper, I'm using the Whisper model in order to generate the transcription in text. As you can see here, it's not the best, but yes, ChatGPT is ChatGPT. But that's a Whisper model actually from OpenAI. And then what I'm doing, I'm splitting the transcription, which we have in a file, into chunks. After that, like the transforming or let's say converting this into embeddings, which are stored in memory in order to do the retrieval. So let's see about what. This is the title of the video. Neural rendering, AI generating images and objects, and advancement in technology for creating images and objects. That's exactly what it's about. And also we can ask another question. Let's see. For example, what future developments or advancements are hinted? You can see here, like it's improved understanding the world of image for image creation, advancement neural rendering, in order to do advancement in creating cooking recipes visually, and even IKEA furniture and so on. That was mentioned in this video. So if you go here, you will find some cooking, some things. Okay, okay, so it was talking about recipes, and then it was talking about different stuff. So we can ask whatever we want, and we will get the answer of it. Let's see if we can ask more. For example, here we are asking, how do these updates position ChatGPT in comparison to other AI languages models? These updates position ChatGPT a versatile AI language model that can generate images and even 3D objects, etc. So let's go a little bit into the code to see what's happening. Sorry, I'm using IDEA IntelliJ since actually I'm a Scala main developer, so I do Python, but yeah, I still like love IntelliJ for my coding. You can see here we have the model, we have app, we have video, we have PDF. We can start from the app since it's a Streamlit app. I guess if someone is not familiar with the Streamlit, it's a very easy and nice way to do POC or proof of concept for any model or data science task.
Could we zoom in code, Dr. Mohammad, because
Yes.
the font is very small.
Yes, just a second. I think I'm missing something here. Yes. Yes. Okay.
If it doesn't work, it's okay, huh? It's not a must.
No, I'm just checking other stuff. I don't know why my API key is presenting since I changed it, but it's okay. I will. Increase font size in all editor. Let me increase it. Alt Shift plus. Okay. We can see here, I think it's a bit better, PDF and video chatbot. So what's happening right now? Okay. We have here the PDF tab. And so what we are doing right now here, we are uploading the file. That's how we upload the file to the, which we extract chunks from PDF. So we are using PyPDF loader in order to load the PDF file. And then what we are doing chunking. As I said before, challenging can be like how to choose the chunk size and the chunk overlap. For example, here I chose like a fixed chunking size, which is 1000 and 100 chunk overlap. Same thing for YouTube video. And then I'm doing splitting the documents into chunks. Afterwards, what we need to do, after having the PDF chunks, we need to get the model, or what's meant by that, like add them to the retrieval, where they are transferred into embeddings. So they are transferred into OpenAI embeddings, but of course, like it's more like ADA embeddings, but you can use whatever embeddings you want. And that's one of the drawbacks actually of using LangChain. I'm using LangChain here. It's not really very customizable. So as you can see here, like we need to have OpenAI embedding for chat OpenAI model, which is a bit frustrating, I would say, since it's not doing much. You can build your own pipeline, you can store your own embeddings, whatever the kind of embeddings you want and whatever the model you're using. And then we can use any model you want. It's not really like I should use OpenAI embedding for chat OpenAI model. It's not ever like that. But for LangChain, it's like that. Here's a model.
Sorry for interrupting, Dr. Mohammad. Just a question. Is it recommended to use the same, let's say, embedding model to extract the embedding from the chunks and later on from the prompt in order to calculate the similarity of the output?
For LangChain, yes, that's what I'm saying. It's a lot of code that's I won't recommend
in general.
Yeah, in general, I would say no. It depends. Like, for example, if you are storing billions of embeddings, you need really like the correct dimension of the embedding. You need really a lot of stuff. Like, should we support multilingual embeddings or not? And that's really important. So there are a lot of criteria, I would say, that you should consider before saying, like, okay, this is more convenient, so I should do this. Since even now, like starting with OpenAI embedding and later I want to use another model, so I will lose everything. Like, I will lose a lot of storage. It's pretty hard to migrate embeddings, like billions of records embedded into another database, into another storage, and do the same thing again, generating new embeddings and so on. So I would say I won't recommend it. I will recommend like going for the embedding you want, and then you can use whatever model you want.
Okay.
Yes. So we have here. It's more like a chain of stuff, since it's a LangChain. So it's almost like a chain. We have the context and the question. That's what's happening here. Is exactly what I described. We have the question of the user being compared to the data inside the vector database in order to retrieve the relevant and similar documents or similar embeddings, which are documents after all, they are text, and then added as a context to the prompt along with the question. So we have the question, we have the context, which are the documents relevant to that question. And then we pass it to the prompt, which is exactly performing this template. So we have to answer the question based on the context below. If you can't answer the question, reply, I don't know. And that's why it answered before, like, I don't know. Since we said, if you can't answer it from the context, say, I don't know. And as we can see here, it's a very simple one. We have the context, which are the documents, and we have the question. And then we have the model, which is the chat OpenAI model. It can be any model as well. We can change the model here, can do whatever. Even I tested it before. It was a hackathon project. For whom doesn't know hackathon, what is it? It's more like 3 days. 3 days. 3 days. We do it every 6 months. in order to work on different projects. It's not necessarily related to the company. It can be related to some features. It's always we have some hackathon winners by learning new stuff and by testing new stuff. So yes, I would say this demo was done in 3 days just to learn more about RAG. In fact, that's it. Yes, so we have the model and we have the parser. Parser, it's more like if you try to print it out without the parser, you will find AI message, blah, blah, blah. So in order to not get the AI message, we use str output parser from language chain as well. So this is the full chain. This is what is being executed. So here, for instance, we are inserting the documents, we are returning a retrieval, and then we are defining that chain based on that retrieval where it's being added here. After that, we have defined the chain. Now we get the model, which is the full chain. So here's the model. Now we are asking the model the questions. So we are just invoking the user input, and what's happening is the user input is transformed, getting the relevant documents and answering the question right away. So here's the response and it's being printed. It's more like a chat thing. Same thing for YouTube, unless it's only one different, I will say. Yes, we are downloading the transcript or we are downloading actually the audio file of the YouTube. And then we are passing it to the Whisper model to transcribe this file into text. And afterwards, this is just to not repeat. Yeah, afterwards we are having we have the transcription.txt stored just beside the Python files. So what we are doing right now, we are just taking text loader, loading the text transcription.txt and trying to do exactly the same thing. Like generate chunks, and after the chunks, embed the chunks into the retriever. And so we have the same thing, like video chunks are being used here in the retriever in order to use the same model and generate results based on those YouTube chunks, I would say, or video chunks. That's a small demo that can highlight what is RAG, how we can use RAG, how we can think about RAG, and yeah, hope it helps.
Yes, sure, it helps. Thanks, Dr. Mohammad. Thanks for the presentation and for the demo. So I have questions, but I will keep the space for others to ask. And then I will contact you in order to discuss the issues I have in my mind, okay?
Yeah,
sure. Fine. So questions, please. Yes, Hussein, just please let's, okay, Hussein, go ahead, please, Hussein Jouni.
It's more of a request rather than a question. Do you have the code that you just shared in a repository you can share with us, or anything like that?
Yes, sure, I can share it with you afterwards.
Yes, thank you very much.
So normally, usually, Dr. Mohammad, what we do, if you can create a GitHub project to put the slides, the code, and everything you want, and you can share with us. So you send me the GitHub project link, and I will share with everyone in the group. Okay?
Yes, I don't mind.
Okay, thank you. So questions? Okay, I will ask one question. So, what did you show, Dr. Mohammad, is something like a question and answer. So I have two questions, in fact. The first one is, could we generate a structured output from using RAG? So it's normally we do that with OpenAI without RAG. So if we have something like a JSON file, okay? One, and two, what if you would like to generate, for example, knowledge relation what entity is related to which entity is related to which entity in the text. So in this case, will OpenAI use its powerful capability in order to extract the knowledge from the document I share with it, or no?
That's exactly what it does. Like usually, we are still using the original model. The idea of RAG is using the original model by giving it more information, more data in order to reason on. But we are still using the original model. So if we can do that with the original model, we can do that with RAG. That's exactly, it's like how it's, let's say, industrialized nowadays. Like in some projects we have, they are using this sort of stuff, same, and generate structured response in order to create widgets and so on.
Okay, great. Maybe I did have the question, the answer, but someone asked me about it, so I would like to. I wanted to pass the question to you, so it's okay. So thank you. More questions? Yes, Mustafa, go ahead, please.
Good evening. I have a question regarding LangChain. I've seen people online posting and complaining about LangChain's boilerplate, as you said. So when do I know if LangChain actually hurts me in, for example, production? And what alternative do I have for tools or agents in general?
Yes. Thank you, Mustafa, for your questions. Actually, you will recognize when it starts hurting, like when you are still like trying to make like going around it in order to fix some stuff, and yes, sometimes like changing the embedding in order to fulfill like or to use this library, it starts here saying like, okay, should I still be using it or not? That's the questions that will pops up like once you have certain inquiries, certain conflicts, and yes, actually for the alternatives you don't need one. That's the thing. Like in case I have vector database and I can do direct vector search over the database, so I can take the user's query, convert it to embedding using some embedding model, and try to retrieve the relevant results from the vector database. Building a prompt won't be that hard, so you can do whatever you want with the prompt, adding those contexts and sending it to LLM. So actually, it's not adding that much if you think about it. If you know the technology, if you know the concepts, it's not really something indispensable from the chain. You can just ignore it, live without it, and you can do much more without it, actually.
Thank you for your answer. Now, I've noticed when I learned it that the two best use cases for it are RAG and agents. Now, for RAG, yes, the concept is implementable from scratch. But for agents, what can we do about them? Can we implement them from scratch?
For agents, yes, you can think about it same way, but I guess some people works with like I didn't work yet with agents that much, but I would say the concept would be more or less the same. Like you can build a full model. Your model will be RAG implemented or RAG convenient, and then you can give it like for agents, for example, I wanted to be specialized in certain domain knowledge or certain expertise and certain tasks to do. So I will give it more information related to that task, to that, let's say, expertise, domain expertise, and so on. So it will perform the same. Like you can use RAG for agents, same thing.
Anyway, next week, inshallah, we will have a webinar related to agents and LLM. So it will be
yeah, I guess as I said before, I didn't work much with agents, so yeah, maybe someone else can answer better than me.
Okay, great.
Lovely. Thank you.
Type, we are running out of time, so Dr. Mohammad, thanks a lot for the presentation.
You're welcome, Dr. Ihab.
We will have you again, huh?
Inshallah.
Inshallah. Type, everyone, thanks for being here. Inshallah, to next week. Yeah.
Thanks, everyone.
Yeah, thanks a lot. Bye.
Yeah.